Hello guys, welcome to another session of Maths with Milind. Today we are going to discuss about congruency of triangles. This is a chapter in 9th standard and is very important. Students think it's complicated, but trust me, it is not. It's pretty simple. So let's have a look. First, what does congruency means? Congruency simply means same shape and size. In short, if two triangles have exactly same shape and same size, it will be called congruent triangles. In short, if I take this triangle ABC, now assuming these two triangles are congruent, right? So if I take this triangle, change its orientation and put it over this triangle, it will completely overlap, right? That is what congruency of triangles mean. That's it. It's very simple. The second thing is, how do you write if two triangles are congruent? So if two triangles are congruent and assuming angle A, angle D are equal, angle B, angle F are equal, and angle C is equal. Angle C is equal to angle E. Then we write the triangle as triangle ABC is congruent to. You must have seen this symbol. There is the congruency symbol with an equals to at the bottom. Is equals to triangle. Now remember, it is in order. It is order based. Since angle A and D are equal, we can't write F over here. This is wrong. Wrong notation. Right? So if two triangles are congruent and you write this notation, it also tells you without the diagram which two angles or which two sides will be equal. So here we will write angle D, then B is equals to F. So we'll write F over here, and then C is equals to E. So we'll write E. So in short, this is how the notation is. Okay, this is your notation. Fine. Now we are taking two triangles as congruent to understand what does congruency means and how do you write it. Okay. There is another concept here, which is a third point. Now, when two triangles are congruent, right, then corresponding angles are equal and corresponding sides are also equal. So in this case, angles you already know because we have defined it in the beginning. What about the sides? How do you know which two sides are equal? So it's very simple. First, let's write the angles. We'll write angle A is equals to angle D, angle B is equals to angle F, angle C is equals to angle E. What about the sides? Very simple. Look at the notation. AB. So if you are taking AB, then DF will be equal. And you can also look here, this angle and this angle corresponds to this and this. So DF and AB are equal. Hence AB is equals to DF. Then what about BC? BC will be equals to FE or EF. So BC will be equals to FE. And what about AC or CA? It will be equals to D, the last remaining triangle. So AC is equals to DE. This is the conclusion drawn if two triangles are congruent. Okay. And there is one more logic which is called CPCT. So you must have heard that term CPCT, or people who are will be going to 9th, they will hear CPCT. CPCT means corresponding parts of congruent triangles are equal, which what we have decided or discussed over here. Now, second thing is, now we have assumed that these two triangles are equal. What if you have a question, and these kind of questions you will get that prove that so and so triangles are equal or prove that so and so sides are equal. So there are 5 rules, or you can say criterions, to prove that two triangles are congruent. Okay, and let's start with the first one. So the first criterion is called SAS. What does SAS means? SAS simply means one side, okay, one side, and okay, let's not call it one side, so we'll call it a side, its included angle, and the other side. So in short, you let's say you have two triangles, right? And this one. So assuming that this side, this side, and this side is equal, and this particular angle is equal. So what does it mean? S A S. It means one side, its included angle means this angle should be included. We can't take these two because it doesn't, it's not between these two sides. Okay, it has to be between these two sides. That's the important part. And the other side, which is this. So side and its included angle. If you have, or if you know from the question, or if you derive this from the question, then you can see that by SAS, these two triangles are congruent, right? So we have a question over here. Let's have a look. How do we show it? So this question says, in the given figure, D and E are the points of side BC. Okay. By the way, this is a very popular question. So D and E are the points on the side BC, okay, of a triangle ABC, such that BD is equals to EC and AD is equals to AE. Show that triangle, now focus on the two triangles which we need to prove congruent. Triangle ABD, which is this, is congruent to triangle ACE, right? So the two triangles in question are, let me highlight this. One is A, let me use a bigger highlighter, A, this is one, D, BD, and the other triangle we are talking about is A, C, and E. Okay, I'm highlighting it so that you guys just focus on these two. Now, question is, how do you prove? As I said, we will be using SAS criterion to prove it. Okay, so let's see. Now, look at this triangle and this triangle. We already know that this side, and this side and this side are equal. In short, one side and one side are equal. We just need to show that this triangle, this angle and this angle are equal. If we show that, then by SAS, we will prove that these two triangles are congruent. So how do you write it? You first write it as BD. So you'll write as, first take this, which are already given. AD is equals to AE. What will you write in the bracket? You will write given and call it S for your reference because you know what criterion you are using. Then angle is still not. Now we'll focus on how to prove these two angles equal. Now assuming this angle is x degrees. If this is x, right, these are the two equal sides. So in short, triangle ADE is an isosceles triangle. And if two sides are equal, then their opposite angles are also equal. So if this is x, this will also be x, correct? So if this is x, then what will be this angle? This will be what? 180 minus x. And what will be this? This will also be 180 minus x. Why? Linear pair, straight line. If it is straight line, then it will form a linear pair. Hence, you can show that angle ADB is equals to angle AEC, which is your included angle. You can call it as 180 minus x to show your reference. Okay, and there is no reason for it. You have proved it by assuming S. This is your A, and then the last side is A, D and AE are also equal. This angle was equal, and the last side is BD and EC are already given. So BD is equals to EC. This is also given. right? Now what is this? You have proved that by SAS, since you figured out that in these two triangles side, included angle and side are equal, hence you can call, hence by SAS criteria, triangle. Okay, now you can use this in the question or you can directly use it. So ABD, ABD is congruent to triangle. A is fixed, right? B is corresponding to C and D is corresponding to E. So these two triangles are congruent. Okay, that's how you use SAS criterion. Hope you guys understood it. If you don't understand it, please drop a comment. I will be happy to explain it again. Or you can rewind and watch the video. Okay, moving on to the next writing. This was SAS. So remember, SAS is the first one. Second is called ASA. Just like SAS, this is what? Angle included side and angle. Okay, let me use the same triangle. My tool, okay, tool is fine. Paste it over here. I'm gonna increase the size. Now what is it? So we'll call it angle. Okay, I'm gonna remove because you only need one side. So this angle is equals to this angle, then you have a side. So angle and angle, right, equals side is equals, and the another angle which is this should be equals. So this gives you ASA, right? ASA, this is your ASA criterion, angle included side and angle. So let's have a look. So we have a question over here. Let me pull this up a bit. Okay, let's have a look at the question for you to understand it better. So there's a figure in which says AB is equals to AC, okay, and angle B is equals to angle C. So let's mark it. Prove that triangle ABD is congruent to triangle AC and E. Similarly, let me highlight it so that you guys focus on these two triangles. So what we are talking about, A, B and D, okay, and then you have A, C and E. So this will be highlighted, but it's fine. Okay, so focus on these two. Now what we are using, we are going to use ASA. ASA means angle, right? And they have already given that AB is equals to AC. So AB and AC will be equal, and A is common, right? So very simple. What will you write? Angle B. So generally we use a three-letter notation. So let's use it. Angle ABD is equals to angle ACE. Reason? It's given. This is what? A, right? Next, side. So included side. This is the included side, right? AB is equals to AC. This is also given, right? Given. This is my S. Let's go to the next page. And angle A is common, right? This is common to both of them. So of course it will be equal. Look at this triangle and this triangle. So angle A is common to them. You can write angle BAC. Try to use a three-letter notation, guys, much better. And CAE, right? So BAC, which is this angle, BAC, and CAE, which is this angle, they are equal. What do you write? Common. Okay, this is common. So hence by ASA, right? Angle included side and angle criteria, triangle ABD is congruent to triangle. A is the common vertex, so first A will come, and you can clearly see that angle B is equals to angle C. It's given here, but you guys check here. Angle B is equals to angle C, so C will come over here, and what is left? E. Put it over there. Is congruent. Clear? So I've taken simple questions so that you guys understand. You can go and practice, and if you have any doubts, please post your question in the comment section. I'll be happy to respond. Okay, now SAS is done. So SAS is done, ASA is done. What is the third one? Remember, third one is AAS. So two angles and one side, if equal, then also two triangles are congruent, right? So what is it called? AAS, meaning any two angles. It doesn't have to be included like in the first two criterions. Any two angles and one side. Okay, so let me take these two triangles again. We paste it over here, right? So what does it mean? Any two angles, right? So I can take this angle now, this angle, and I am gonna get rid of this particular angle, and I'll say this is equal. So if you see two angles and any side, okay, it can be this side as well, it doesn't matter. So, and the side doesn't have to be included between these two angles. So that way also two triangles will be congruent. Let's have a look at this question. So it says in the given figure, AB is parallel to CD. Okay, these two are parallel. You can see by the arrows. O is the mid and O is the midpoint of AD. Okay, meaning AO and OD are equal. Show that AOB is congruent to AOB is congruent to DOC. Let me highlight this again for you. The two triangles in question are this. Okay, so let me highlight this. Another one is this one. Okay, now we'll be using AAS, right? Another reason, so I've taken examples, but you will be questioning how do I know which criterion to use? Depends. If two sides are given equal, or it's pretty evident from the figure, use SAS. If two angles are given, then try to use AAS or ASA. Right? That's how you can figure out based on the information given to you. So here the information given is only one side is given. So this is the most probable case that this can fit. So one side will be equal. What about angles? None of the angles are given equal. No problem. I am gonna remind you about lines and angles. What are these? These are parallel lines. So extend it, right? You remember you used to see a figure like this. Extend this, extend this. If you remember parallel lines and transversal concept, these two triangles are what? These are interior alternate angles, right? Similarly, if you take these are also interior alternate angles, right? So the angles are given, they are equal, but they are not given directly. You will have to use the parallel lines and transversal concept, right? So this angle is equals to this angle, and this angle is equals to this angle. So can you see two angles and any one side are equal, hence by AAS. Now how will you write it? We'll write it like this. Angle BA. Okay, so you're talking about BAO is equals to angle ODC. Why is it equal? Because of interior alternate angles. This is your angle. Okay, BAO, which is this, is equals to ODC, which is this. Similarly, angle ABO is equals to angle OCD. Again, same reason, interior alternate angles. we have another A equal. And one side is already given equal since O is the midpoint of AD, hence OA is equals to OD, right? This is what? This is given. This is what? AAS. So what will you write? Hence, by AAS criteria, triangle AOB is congruent to triangle. Now A corresponds to D. We have already seen over here. A and D are equal. So D, O corresponds to O, it's common, and B corresponds to, there's only one thing left, C. Triangle DOC. Okay. So these two are congruent. Now coming to another point. Prove that O is the midpoint of BC as well. How will you prove it? New technique, by CPCT. Meaning what? CPCT means corresponding. Remember the first page, corresponding parts of congruent triangles. They are equal, right? They are equal. See this. This is nothing but CPCT. If you know that two triangles are congruent, you know that all the corresponding angles and all the sides are equal, right? So see this. We need to show that these two are equal, right? If you show OC is equals to OB, you have proved that O is the midpoint of BC. And here you can clearly see that OB is equals to OC, right? Since, and you will write since OB is equals to OC by CPCT. I've already written, so anyways, it's fine. So by CPCT, you will write OB is equals to OC, hence O is the midpoint of side BC. Okay, hence proved. Moving on to the fourth criteria, it's called as SSS, and probably this is the easiest. So what it means, as you can see the name, all sides are equal. Okay, it shortly means all corresponding sides are equal, as I'm just calling it all sides are equal. Now let's look at the question. Okay, let me quickly show you through a small diagram what it means. It simply means that one side is equals, other side is equal, and third side is also equal. So in short, corresponding sides are equal. All three sides will be equal. Best example is prove that two equilateral triangles are congruent, right? Now let's have a look at these two triangles. Let's say these are equilateral. So A, B, C, and D, E, F, right? Very simple. You still need to write it though, right? Even if it's pretty visible that all three sides are equal, you still need to write it. So what we'll write? We'll write AC is equals to DF. You can just say given. Then you can write BC is equals to EF. Again, given. So this will become S, and the last side AB is equals to DE, given. What will you write? Hence, by SSS criteria, triangle ABC is congruent true. Now have a look. Angle A. Now angles are not given, right? The sides are given. So AC is equals to DF. In short, A and D will be equal, right? And you can look like this as well. See, this side and this side are equal, and AB and DE are equal. So they are pointing to which angle? You can imagine like an arrow, right? So it is pointing to D. So angle A is equal to angle D. Similarly, if you talk about B, then you have AB and D equal. Then you have BC and EF equal. Which triangle are they pointing towards? E, right? So we have E, and the last one is F. So triangle ABC is congruent to triangle D if F. Okay, triple S is the easiest and most probably you won't get it. Or if you get it, then you're lucky. Okay, moving to the last one. This is known as RHS. What is R? R stands for right angled triangle. So in this, first of all, how will you check? How do you apply this rule, or when do you apply RHS? When you have a right angle triangle, first look at RHS. So what is the criteria? The criteria is because it's right angle, right? Both of them will be right angle triangles. Your angle is already equal. So we don't talk about it. All you have to check is hypotenuse, okay, and any one side should be equal. If you have this, you call it RHS. So R for right angle triangle, H for hypotenuse, S for any one side. So if I have to draw, let's draw two right angle triangles. Okay, this is one. Let's draw the other one. So we will say, okay, hypotenuse is equal. We have claimed it, right? This is 90 degrees. So by default, it's just gonna be equal. And any one side. So you can say, let's say this is ABC and this is DEF. So we'll say AB and let's say D, they are equal. So we can say that these two triangles are congruent. Why? Because hypotenuse is equal. Right angle triangle is already there, so you don't talk about it. That's why you're calling it RHS. Just look for hypotenuse and side and any one side. So AB is equals to DE. AB can also be equals to EF. It doesn't matter whether it's the base or it's the perpendicular. Let's have a look at a question. In the given figure, BA is perpendicular to AC and DE is perpendicular to DF. Okay, show that AB is equals to DE and BF is equals to, oh sorry, this is such that, sorry, AB is equals to DE and BF is equals to EC. So these two are equal given. Show that triangle ABC and triangle DEF are congruent. Let me highlight it so that you guys can focus. Anyway, there are two triangles, but I'll still demarcate it. This is one. The next one is the below triangle. Okay, I'll not worry about the drawing. So these are the two triangles. One is this, one is this. Now, how do you know you have to apply RHS? Because both are right angle triangles. So the best possible case is you look for your hypotenuse. So first check for hypotenuse because side is anyways equal. That part is sorted. If you prove that BC and FE are equal, you are done. We will prove by RHS that these two triangles are congruent. People who don't know what is hypotenuse. Angle side opposite to the right angle triangle in a right angle triangle is called hypotenuse. So this is a right angle triangle, this is a 90-degree angle. This is the side opposite to it, hence FE is the hypotenuse of triangle FED. Okay, so BC is equals to FE. We need to prove it first. How will we prove it? We don't have any condition. So let's try to use BF is equals to EC is given. Let's see. So can we write BC? Okay, let's write BC. BC can be written as, what is BC? BC is nothing but BF plus FC, right? BF is equals to FC, right? So we can write it BF plus FC. Let's call it equation 1, right? Then similarly, let's talk about this. So FE can be written as CE plus CF. Okay, addition of two sides. So CE plus, or you can call it FC. You can clearly see that since what BF and C, they are equal, right? It's already equal. So we can write, or we can say, by comparing equation 1 and 2, BC is equals to FE, right? I hope it's clear. FC are already equal, BF and C are already equal, hence FBC and FE will be equal. And this is what? This is nothing but your hypotenuse, correct? So if BC is equals to FE, it means your hypotenuse is equal, you can call it H. AB is equals to D, already given. So any one side, okay? Any one side can be equal. It's already given. AB is equals to DE, given. Okay? S. Hence, by RHS criteria, triangle ABC is congruent to triangle. Now, A is 90, D is 90. So they will be equal, or you can copy it from here, but try to practice. So A and D are equal. So this will be D, right? B corresponds to which angle? B will correspond to E, right? So ED, EF. Hence, proved. Okay. So that's how you will do a question. If you have right angle triangle, look for RHS. Okay. If all three sides is given and no angles are given, then look for triple S. If you have two angles given and one side is given equal, look for third, which is AAS or ASA. The ASA is written because it is angle included side. Okay, remember included side. In double AS, you don't need to include the side. It can be any side. And the first one was SAS. And remember, there is no SSA. Okay, there is no SSA. It's only SAS. So they are just five. Don't create any more criterions from your side. You will have to limit your thinking to these five criterias and then do your congruency question, right? And as I said, it's very easy. The first page is all about if two triangles are congruent, what is CPCT and how can you use it, right? These are the conclusions, that corresponding angles, corresponding sides are equal. This is the prelogue. Like, first prove that two triangles are equal. How will you prove two triangles are congruent? By SAS or by ASA or by AAS or by triple S, and if you have a right angle triangle, go for RHS. Okay, hope this session have helped you. If it has helped you, please do like, subscribe, and if you guys have a problem and if the explanation is not clear, please do comment. I'll try to respond back. Even if you have any questions you're not able to solve, please, this is an open forum, so post your questions and we can discuss about it. Thank you.